Please subscribe to my channel and press the bell icon for latest updates.
Hello guys, Amal Ratheesan here and welcome to my new video. So this is the 6th episode of the data structures and algorithms in Python course. Haha. So today we're going to discuss about recursion versus iteration. So we know recursion is simply a function calling itself, and iteration is just a repetition of a same process to get an outcome or output. That's all. So both recursion and iteration are important in computer science. Today we're gonna compare them. Okay, so we have two programs here, two functions, both do the same process, but they are entirely coded different. This is simple code, actually just few lines, and this is a little complex, but actually this is very this is not space efficient, and this is very space efficient, all the things, and this is not time efficient. The only thing good with recursion is it's very easy to code. So let's take a look into it. Here we defined a function power of 2. Okay, n is the parameter, and if n double equal means if n equals to 0, return 1, else power equal power. Here the function is calling itself power of 2 n minus 1, return power of return power into 2. Okay, so let's take a pen and a paper and just write it down. Write the function down. We will find the output, how the program works. So just give 3 as the parameter n. Okay, 3. So we need to know 2. The power of 2 means 2 raised to 3, 2 cube. Okay, we need the output. So 3. Just give 3 as a parameter. If 3 double equals 0, no. Okay, then else statement. Power equal power of 2, power of 2 2 power of 2 2. So we just gave the function as so power of 2, we are just simply call p of 3. Okay, power of 2 3, we call it power of p of 3 instead of power of 2 3. It's very easy to say. So the first is p of 3, and here the power will become power of 2. Okay, the p of 3 then gives the control to p of 2, then we come to p of 2, then again p of 2, the output will p of 1, then p of 1, p of 0. So we have the we have a value for p of 0. Actually p of 0 is 1. So in the we have the stack memory, right? As in the last class we have seen how the recursion was. So that the p of 1 is at the top of the stack memory. At the bottom we have p of 3, and above that p of 2, and above that p of 1. So we have the p of 0 means power of 2, 0 equal 1. So and then we go back to p of 1. P of 1, we have power equal p of c, power of 2 0. We know the answer. This is 1. So return 1 into 2. So the power of 1 is 2. So then we pop the p of 1 from stack memory, and we'll go back to p of 2. So p of 2 equal power of 2 1. Power is equal power of 2 1. We know the answer of power of 2 1 is equal 2. So return 2 into 2 4. The p of 2 will return 4. So we'll pop the p of 2 from the stack memory, and we the remaining is p of 3. Come to power of 2. P of 3 means power of, I just shortened it, power of 2 3. So power equal power of 2 of 2. We know the answer of power of 2 of 2. Power of 2 of 2. Okay, power equal power of 2 to 4. Okay, return 4 into 2. So answer of P of 3 is equal 8. 4 into 2 8. So 2 cube 2 into 2 into 2 equal 8. That's how the recursion works. Actually, the pushing and popping is done in the stack memory. It's very time consuming, space consuming, all the things. So in this case, it's a simple iteration. Actually, if we give the 3, just set I is equal to 0, power is equal to parameters, and there is a while loop, and it's very fast, very faster than this code. Okay, so the main thing is no stack memory is required in the case of iteration. So in the case of iteration, there is no need of stack memory. And in the case of recursion, systems needs more time for pop and push elements to the stack memory, which makes recursion less time efficient. So here we have the table. You just need to study the table. Actually, in the course, I just says about all the things we need in data structures and algorithm, and with that you can learn any new kind of programming, and just need to know the syntax of that programming language. Okay, so then why do we use recursion? We use recursion when there is little amount of time to code. So recursion statements will be very less, 2 lines, that's simple. Okay, and if a problem can be divided into similar sub problems, we will use recursion. So that's it, guys. So it's a simple video. Thanks for watching this video. Keep watching my videos and please subscribe. Okay.